Welcome back with another video on TryHackMe.com. This is Ahinas here, and we are doing DevSecOps. So, before we resume our learning on the DevSecOps, let's see what we have done already. We have covered the secure software development module, security of the pipelines, and security in the pipelines module. Now we are on to container security, where we learn how containerization works and its benefits, potential vulnerabilities, and steps necessary to secure your container. This is what we gonna learn. But for today, we're gonna go for intro to containerization room. Okay, so before we proceed that, let's see where we are on the overall progress of DevSecOps path. So estimation completion date is 31st July. They're saying you are a bit behind. Let's see what they will say after we complete this room today. Certificate progress is 58%, and the next achievement will be after Deploy Docker vulnerability room. So let's get into this room, intro to containerization. Awesome. Okay, I click on the containerization link. It is loading. Okay, let's go with the stats. What we're gonna learn: the path is DevSecOps, container security, and intro to containerization. And we will learn about the technologies and benefits of containerization, and it is easy and it will take 30 minutes. That means it will take around 40-45 minutes for us because we do a lot of explaining in this room. I can see that there is no attack box, but there is a task with some website here. So let's see the introduction here. This is the first of a series explaining the popular technologies of containerization. Awesome. Learning outcomes. By completing this room, you will know, okay, what containerization is and what containers are. Very good. Where and why containerization is used. Of course, a fundamental understanding of popular containerization technologies called Docker, Cryo. There are many others, right? What makes Docker so popular? How containerization works? With that said, complete the question below and progress on to the next task. We already done so. Let's move on to the task 2. Okay. What is containerization? We have a container which is opened here. In computing terms, containerization is the process of packaging an application and necessary resources such as libraries and packages required into one package named as a container. The process of packaging applications together make applications considerably portable and hassle-free to run. Yes. Why considerably portable? That means you take this container, you run in staging environment or production environment, it will run the same. There will be no thing like it is working on staging but not working on production. This could be, but these kind of excuses are limited or minimized. Like 90% of the issues are minimized. Okay, container is kind of a VM, right? Which have binaries and all the libraries and everything, and it is packaged together as a container. Okay, modern applications are often complex, usually depend on frameworks, of course, and libraries being installed on a device before the application can run. These dependencies can be difficult to install depending on the environment the application is running. Some operating systems might not even support them, of course. Create difficulty for developers to diagnose and replicate faults, as it could be a problem with the application is an environment, not the application itself. Of course, the environment, I mean the VM environment, the OS environment itself, can often conflict with each other. For example, having multiple versions of Python to run different application is a headache for the users. And an application may work with one version of the Python, not with another. Okay, that is very relevant use case to consider, because even the Python 2 is different than the Python 3. So if you take Python 2 code and try to run it on Python 3, usually it will not run. You need to upgrade it before you can run it, right? And also running a lot of application on the same VM with different versions of the framework is not recommended, because if you fix some vulnerability in one of the version, it could affect other version as well. So that's why containerization, because it will give you the portability and the right footprint for application to run upon. Okay, I will explain a little bit more what I meant by that once we move forward. Containerization platform remove this headache by packaging the dependency together. Yeah, they are explaining it. And isolating. Isolating is the right word to use here. Now, this is not to be confused with security isolation. In this context, the application's environment. The context is the application environment. If the device supports the containerization engine, a user will be able to run the application and have same behaviors. Same behaviors, I mean, staging, dev staging, pre-prod, UAT, production, QA, wherever. A diagram demonstrating 3 containers on a single computer. So consider this is the physical computer, then the computer operating system, which we call host operating system, and then you have Docker engine. Sometimes Docker engine can also be installed directly on the physical computer, removing its computer operating system. Okay, so sub Kubernetes. Kubernetes is basically the management system for Dockers. It could be installed directly on the physical without installing it or adding one more layer of the computer operating system here. Okay, this could be done, but generically this diagram is right. Docker engine, and then we have container 1 with application 1 in environment, container 2 with application 2 and environment, container 3 with application 3 and environment. Environment means the OS and all the libraries that it needs to be. And that means if it is a container, it will have a small footprint as well, not a whole OS. It will require a sub version of the OS, or the subset of the actual OS. Okay. In the screen above, you can see how 3 applications and their environments, such as dependencies, are packed together and do not directly interact with the physical computer, but rather containerization engine. In this case, it is Docker. So containerization engine, which is managing all the containers, is Docker engine. Okay. All right. Let's move forward. We will come on to discuss precisely how containers isolate from one another. But for now, it is important to understand that this isolation is a core feature of the containers. This environment as isolation is a core feature of the containers. However, it is worth noting that containerization platform make use of the namespace feature of the kernel, which is a feature used so that processes can access resources of the operating system without being able to interact with other processes. Okay. So they will be using namespaces. So for example, one process cannot go to another container and try to interact with the other container process unless this is allowed by the Docker engine itself. Okay. The isolation offered by namespaces adds a benefit of security because it means that if an application in the container is compromised, usually unless they share the same namespace, other containers are unaffected. So in this case, I mean, on one Docker engine, in one namespace, usually all the containers that are deployed are represented for only one application or representing only one application. So it could be, for example, google.com is an application, is a search application, and their container could be running like millions of containers are running on Docker engine. Okay. So if you compromise one container, that means similar kind of things can be applied to other containers as well because they represent the same application. So, okay. So this is what they are explaining in here. Okay, let's move forward. Alternatives such as virtual machines will require a whole operating system being installed to run the application. That's true. Taking up large amount of disk space and other computing resources such as CPU and RAM. Yeah, I mean, even containerization require a lot of CPU and RAM and disk space, depending upon how many images you are creating. Okay, but overall, the running cost of the container is much lower than the VM itself. So that is where, for example, in one of the video that I was watching about the Google data centers, they were explaining that even 1% of a factor in CPU and RAM resources reduction could mean that one data center itself. Okay, so if you reduce 2% of the resources that are required to run same workload, that could mean two data centers of Google. So even a small optimization at that level or company level uh, could mean a lot. Okay, what is the name of the kernel feature? But in our sense, it could be like, okay, we are not a big company, so it could mean that, okay, what is the difference between we're using a virtual machine or the containerization? But if you think about in a bigger context, you will be able to understand all of this. Answer the question below. What is the name of the kernel feature that allows for processes to use resources of the operating system without being able to interact with other processes? It is namespace. So namespace, here it is. I'm a big fan of copy pasting, so I'm gonna copy paste here. All right. In a normal configuration, can other containers interact with each other? No. All right. We're moving through task 3 now. Okay, up to the task 3 now. Okay, introducing Docker. So this is Moby Dick, and something is going on in this picture. I don't know about that. We have shipped have ya, Captain Ahab, Moby Dick. Okay. I promise I will try to keep the sales pitch relatively short. Docker is a relatively hassle-free, extensive open source containerization platform. The Docker ecosystem allows applications, images will come into this in a later room to be deployed, managed, and shared with ease. Working on Linux, Windows, and macOS, Docker is a smart choice for applications. For running applications, applications can be published as images and shared with others. All that is required is pulling, downloading the image, and running it with Docker. Docker employs the same technology used in containerization to isolate applications into containers called the Docker engine. The Docker engine is essentially an API that runs on the host operating system, which communicates between the operating system and containers to access the system's hardware such as CPU, RAM, and networking and disk through namespaces, which is a feature on the kernel that we read before. Before of this, the Docker engine is extensive and allows us to do things like, okay, connect containers together. For example, a container running a web application and another container running a database. Okay, export and import applications images. We'll talk about these images in a room after that. Transfer files between operating system and container. Of course, Docker uses the programming syntax YAML. That YAML is and markup language is a data serialization language that is human readable and useful for managing data. So it is the next version of JSON. Okay, it requires less character to represent the same kind of data using YAML to allow developers to instruct how a container should be built and what is run. That is a significant reason why Docker is so portable and easy to debug. Share the instruction and it will build and run the same on any device that supports the Docker engine. Of course, it's kind of similar to CI/CD, right? You give some instruction, it will run. For example, you take the base image, you run or installs few requirements on top of it, and then you copy paste the binaries, and lo and behold, your container is ready. You need to tell that on which port it will be exposed to the external and on which port it will be exposed internally. So all of these are managed through container instruction using YAML file. Okay, the Docker engine allows container to be orchestrated. Okay, meaning that multiple containers can be built as part of a group, allowing containers to communicate with each other. For example, one container running a web server and another container running a database can communicate. We will come into this feature in a later on. Okay, no problem. What does an application become when it is published using Docker format and xxxx fill the access? What does that mean? An image, I think. Yes, it was a wild guess, but yeah. What is the abbreviation of the programming syntax language that Docker uses? YAML. All right, so we are on streak 10. Awesome, awesome. Okay, let's move on. We are on task 4. We are 15 minutes into it, so hopefully by the end of this video, we'll be done with this room. Okay, the history of Docker. Originally created by Solomon Hykes. Apologies for pronouncing not correctly. In 2013, Docker is open source and has become a well-renowned name within the containerization. Docker started as an internal project for Dart Cloud, a PaaS provider, where it was then showcased in PyCon in 2013 and then quickly made open source. And Docker itself, the containerization technology, was, I think, secret project within the Google itself. They were using what you say cyborg system within their data centers. So all of this came. I'm explaining about the Kubernetes, not the Docker. So apologies. So the Kubernetes itself, if you know about that, was a secret project within the Google, and then the Red Hat and Google collaborated with each other and bring the Kubernetes technology to the open source community. So Docker is a different thing. While containerization original concept started in 1979 with Unix v7, Docker has made containerization a popular technology since it released in 2013. Docker's popularity is due to making the benefits of containerization accessible and modern. Accessible mean easier to do programming on the Dockers, and if you need to do any Docker programming, just install a Docker with a suitable hardware, and you can do and run. You can basically run any Docker images on top of the your own laptop if it does support the virtualization. As of April 2022, it is fair to say that Docker is extremely popular. To be precise, 13 million developers are using Docker. There are 7 million applications made and ready to use with Docker. 13 billion applications are downloaded monthly. And this is just from the official repository, which is dockerhub.com and docker.com. So both of these are references here. In what year was Docker originally created? 2013. This is where everything started. Where was Docker first showcased? PyCon. Okay. What version of Unix had the first concept container there? V7, I think. Yay, of course. Moving on to task 5, it is the benefits and features of Docker. Okay, so we have gear icon here. What's all the first, you ask me? Okay, and it is from me. If it hasn't been said enough, here is another attempt. Docker is an agile, convenient, and extensive means of deploying an application. That is correct. Let's explore this in detail in the headings below. Docker is free. Docker's ecosystem is free to use, open source. While business plans exist, you can completely download and use, create, run, and share images, of course. Docker is compatible. The Docker platform is compatible with Linux, macOS, and Windows because of how containerization works. If a device supports the Docker engine, you can run any container regardless of the application or dependencies. It is mostly generally true. but sometimes it is not true if the container is highly specialized container. Docker is efficient and minimal. Docker is an efficient way to isolate applications in comparison to alternatives such as virtual machines. This is true. This is because the Docker engine runs and interacts with hosting operating systems, and containers do not run a fully fledged operating system for each container. That is true. For example, containers can share a minimal operating system image, meaning you only need to store it once. Minimal Ubuntu image is 100 MB container image, which can be stored once and used multiple times. Compare this to the Ubuntu server image, which is about 1 GB after a fresh install per VM, even more than 1 GB nowadays. Okay, so this is what they are showing: Docker image ls, and this is a repository on the THM, and Ubuntu latest version is 77.8 MB. Awesome. Docker is easy to get started with. Docker developer documentation is very well documented. You can click on this link and go through Docker documentation with lots of articles, working examples, and answered questions on the internet. The chances are, if you want to do something in Docker, someone has already asked about or done it. The syntax to get started with Docker is easy to pick up. You can start your first container in no time. The fact that there are Docker images for all sort of applications already published helps. Docker is easy to share with others. Of course, a significant benefit of Docker is its portability. Docker uses images, and you can share your images with anybody if images are public, are stored in public hub. Otherwise, if you are using Docker for private development, then you need to store these images to private hub, not the public one. To store instructions to dictate how the containers should be built, just an instruction manual. These images can be exported, shared, and uploaded to both public and private repositories such as Docker Hub and GitHub. The image can be run by anything that supports the Docker engine as long as the syntax is valid. Docker is minimal. They told us this before here, minimal. Again, Docker is minimal. Docker image discusses above. Docker images discussed above are minimal. You will often find many core and luxurious tools and packages in a container that are missing. While this can look like a disadvantage, it in fact allows container to be built exactly how the developer wishes. Better security, knowing exactly what runs within a container, can reduce the risk of unnecessary packages becoming vulnerable and posing a security risk. Yeah, if you are reducing the surface area, that means you are reducing the risk on top of regarding that particular technology where you are reducing the surface area. Docker is cheaper to run. Running container is usually a cheaper option than running virtual machines. This is especially noticeable in cloud environment where CPU, RAM, and disk space are expensive. For example, you can quite happily run a few containers on a single $5 cloud provider VPS, whereas you will not be able to run a virtual machine. This is due to the fact that running virtual machines require hardware that support virtualization, which is only found on a costly tier of the cloud provider, if at all. Virtual machines requires a lot of memory and disk space, as you are running a separate operating system on top of the physical machine. That is very, very correct. But also, containers are cheaper if you are running them in a bulk. Okay. We are moving to task 6. How does containerization work? Okay, let's see. Gear icon, and then we have namespaces. Essentially segregate system resources such as processes, files, and memory away from other namespaces. Each process running on Linux will be assigned two things: a namespace and process identified PID. Namespaces are how containerization is achieved. Processes can only see other processes that are in the same namespace. No conflict in theory. Take Docker, for example. Every new container will be running as a new namespace, although the container may be running multiple applications in turn processes. Let's prove the concept of containerization by comparing the number of processes that are in a Docker container that is running a web server versus the host operating system at the time. Okay, so they are showing that we have cmnatic, and then we have root, and then we have Docker build here with Docker Apache, and then we have opt Google Chrome. Put simply, the process is with a ID of 0 in the process that is started when the system boots. Where is the ID, guys? Okay, these are the IDs 0.0.0. Okay. Started when the system boot, process number increment and must be started by another process. So naturally, the next process ID will be 1. This process is the system init, for example. 1 is where we cannot see here. Maybe this one. I'm not sure where. What they're referring to. Maybe this one. Okay. In it, for example, the latest version of the Ubuntu use systemd. Any other process that runs will be controlled by systemd process number 1. Systemd. I cannot see even systemd here, but okay, let's move on. We can use process 1's namespace on an operating system to escalate our privileges, whilst containers are designed to use these namespaces to isolate from each other. They can instead coincide with host computers' processes. This gives us a nice opportunity to escape. This is how they have shown us. This is the root one, and all other, as you can see, have PID. For example, www.data have 15, which is running on Apache, and here we can see that it is 1.0 cybernetic and cmnatic, sorry, and this is running Google Chrome here. And we have init as well here, which is 0.2 run init SSL. Okay. What command you use to view a list of running processes? I'm not sure, but psaux. This is what it is written here. Awesome. We have done it. So deploy the static attach to the task containerization the application to reveal the flag. Okay, let's see what we have to do exactly here. So we have physical machine. Then we have physical machine OS. Then we have container engine. Then we have container OS, and then we have application itself. Yeah. So I will copy this and put it here. Awesome. Congratulations. You have done this, bro. And we have done this under 30 minutes. That is awesome. And thank you guys for joining me on this journey. It is a lot rewarding for me. Basically, I made halfway through, and we're still continuing to do that. It is really, I really feel blessed to be a part of this journey, guys. So thank you very much for all the support and love on this channel. And if you haven't subscribed, please subscribe. Give the thumbs up, and if you have any comments, please mention it down below, and I will see you in the next video. Bye bye.